All right, so the end of the last lecture we were talking about using and creating objects. All right, so remember that so a Java program typically consists of many, well, not necessarily many. A typical Java program consists of interacting objects. Right? Where do the objects come from? Well, the programmer creates them, right? Which sort of implies that objects all have a lifetime of some kind, right? They're created, they're used, and then they go away when you're done with them. The programmer doesn't have any, the programmer doesn't really do anything special to make objects go away, right? So in other words, there's no way for the programmer to explicitly remove an object from a program. However, the programmer is responsible for explicitly creating an object. Right? And the way you create an object is typically using the new operator combined with a constructor. Right? Remember what a constructor is? A constructor is this thing that looks like a method. It's not actually a method. It happens to have the same name as the class that you want to use. It's the thing that initializes the state of an object. Right? So there's no guaranteed constructor for a class. Right? The only way you can figure out which constructors the class has is to go and look at the documentation for the class. However, there are some common types of constructors that many classes implement. Right? Many, not all. One of them is the no argument constructor. Right? So the no argument constructor, that's the constructor that has no caller specified inputs. When you call the no argument constructor, which is shown in red, right, it's just the name of the constructor and then the pair of round brackets, no arguments inside the round brackets. Right? What does this constructor do? Just a second. What does this constructor do? Well, every constructor does the same thing. It sets the state of an object. Right? So the no argument constructor sets the state of an object to some specified default state. Right? Who specifies the state? It's the creator of that class. Right? So whoever wrote that point2 class has decided that there is such a thing as a default point. Right? It turns out for this class, the default point has the coordinate 0, 0. Right? So whenever you use this constructor, so whenever you write new point2, round bracket, nothing inside the round brackets, you end up getting a point object whose coordinates are 0 and 0. You had a question?
Is it defined in the language that constructors must match the class name?
Yeah, so the question is do the constructor name, must it always match the class name? And the answer is yes. The name of a constructor is always the same, exactly the same as the name of the class. Right? That is a rule of the language. If you try to put in something that doesn't have the same name as the class, you'll get an error when you try to compile your program. Right? So that's the no argument constructor. Not every class defines the no argument constructor, but many do. There's another type of constructor that is, I would say, less common than the no argument constructor. It's called the copy constructor. So the copy constructor has one input, right? It's typically of the exact same type as the class itself. So point2 has a copy constructor that takes in or accepts a point2 reference as an argument. So here in this example, P2, that's type, P2 is a variable whose type is point2. Right? This particular constructor takes a reference to a point2 object and makes a copy of the passed in object. Right? So this constructor call here makes a copy of whatever point P2 refers to. Right? So P2 is back here. It made the point 1, 0.5. Right? So that constructor there makes a copy of that point there. And so the third point also has coordinates 1 and 0.5. Right? It creates a new object. So this point here is different, right? It's a distinct point compared to the previous point. Right? So there's two different points. They both happen to have the same coordinates. If you change the coordinates of one point, then the coordinates of the other point do not change, right? They're independent objects. Not every class defines, strike that, a copy constructor. But if a class does define a copy constructor, then that's probably the intended way to make a copy of an object using that class. And finally, a class can define as many constructors as it likes, subject to certain constraints. So This particular example defines a third constructor, that takes in two double values, and it initializes a point so that its coordinates are the specified double values, right? So that's the x coordinate of the point, and that's the y coordinate of the point. Right? And so whoever made this point2 class created a constructor that takes in a double and a double, and the purpose of those two values are to set the x and y coordinates of the point. Right, here's another example using the scanner class. So the scanner class has multiple constructors. It has many more than what I'm showing you here. Right? That constructor call there, that makes a scanner object that can read the keyboard. Right? That scanner constructor call there makes a scanner object that can read the contents of a string. All right, so once you've made your object, right? So you've called new, and then you've called the constructor. You now have a reference to an object. It's now time to use the object. So there's no way for a programmer to access an object directly in Java. Right? So in Java, the programmer never gets hold of the actual object itself. Right? All the programmer has is a reference to the object. Right? So if all you have is a reference, then the only way that you can use an object is via a reference. Right? And so what that means is that you typically have a variable. Right? The variable will have reference type. Right? To ask the object referred to by that variable to do something, you use the name of the variable, then a period, then the name of the method that you want to call, and whatever arguments are required by the method. Right? And so that's typically how you ask an object to perform some action. Right? If the object has a variable that's visible to you, right, or to the class, well, I guess that's the easy way to put it. If it's visible to if it's visible to you, if it has a field that's visible to you, then you can access the field name in the same way, right? You use the name of the variable, dot, and then the name of the field. Right? Okay, so here's an example. I make a point2 object up here, right? So new point2, its coordinates are 0.5 and 0.1. Right? I get a reference to that object, and I store it in the variable p. Right? And then I would like to know what is the coordinates of the point p. Right? So p.x says, hey, object referred to by p, what is your x coordinate? Right? And it turns out this method returns the x coordinate as a double. So you get 0.5. Right? p.y asks the point referred to by p, what is your y coordinate? And the method returns the value as a double. So that gives you back 0.1. I'm now going to change the value of x and y. Right? So when I change the value of x and y, it's that x and that y I'm changing. Right? I'm not changing the coordinates of the point yet. Right? I'm just changing the values of x and y. Right? So change x and y, it doesn't matter how you change them. Right? I can then ask the point p to set its x coordinate to the new x value. So the class point2 has two methods called x. Right? The first one returns the value of the x coordinate. The second one lets you set the value of the x coordinate. Right? So here p.x round brackets x sets the value of the x coordinate to 0.6 in this example. Right? And p.y sets the value of the y coordinate to 0 in this case. Right? If you poke around in the point2 class, you'll see that there's actually a method called set that lets you set the x and y coordinate at the same time. Right? So these two lines of code could be replaced with that one call there. Right? Oops, sorry. Right? So to call the method, variable name, dot, method name, round bracket, pass in whatever arguments you need. Right? The class may have multiple methods with the same name. Right? If they have multiple methods with the same name, you have to look at the documentation to figure out exactly how do I call the method that I want. Let me just quickly flip to Eclipse here. So you have access to all this source code. So there's a zip file that you can download from I think it's on OnQ, but you can also get it from my GitHub if you have access to the GitHub or if you know where it is. And you get all the source code that's used in the course. There's a lot of it. So it's inside this project called CISC124. Right? If you look at the 124 project, you'll see there's a lot of source code available to you to look at. Right? Under the package notes, basics, geometry, you can find the .2 class, which is right here. Right? And if you scan through the .2 class, you'll see it's quite long. Right? But you'll see that you'll see that in front of all of the constructors and methods, there's documentation for what the constructors and methods do. Right? And you see, it's actually quite a large class, right? So it's capable of doing quite a large number of things, right? It has many methods. We're going to look at many of the methods in the class as we progress through the course. Okay, here's a little example of using a .2 using the .2 class to do something that's slightly interesting. Right? I'm just going to run it, and then I'll explain what's going on. This class doesn't exist in the notes, but you can easily make it. Just copy that main method into a class of your choosing. Right? Make sure to import the .2 class if you need it. Right? You'll also need a second class called standard draw, which is right there. Right? But once you have that, you can draw simple shapes. Right? And so what this program does is not the most exciting program in the world, right? But it makes a ball that bounces back and forth on the screen. Right? And all it does is it just uses a .2 object to figure out where there's a ball at every time step. Right? So that line there makes a point. Right? It starts out at 0.5, 0.5. In the program, that corner there has coordinates 0. The top right-hand corner has coordinates 1, 1. Right? So everything here is inside the unit square. I'm going to make a variable called radius. Its value is 0.1. I don't know if I've explained what a final variable is yet. You can mark a variable or a field as being final. Right? So if you mark something as final in Java, or a variable as being final in Java, what that means is that you can set the value of the variable exactly once. Right? It doesn't matter when you do it. You have to do it before you use the variable, but you are allowed to do it exactly once. Right? So here, I set the value of radius to 0.1. Right? Typically, when you do this, you're making a constant. And when you make a constant, it is acceptable to give the name of the constant in all caps. Right? So that's all that line is doing there. So the radius of my ball is going to be 0.1. The value dx, that's the distance the ball moves at every time step. Right? And now this just runs an infinite loop. Right? So while true, so there's a while loop in Java. Hopefully they showed you a while loop in Python. Right? It works the same as in Java, as in Python. It's while, right? Some condition, right? If that condition is true, the loop runs. If it's not true, the loop doesn't run. And that condition gets checked before every iteration of the loop. Right? So while true makes an infinite loop. Right? And then all we do is we just move x, the x coordinate of the point by the amount dx every time. If you reach the right-hand edge of the window, right, I'm going to switch the value of dx. So I'm going to make it negative, right? And that makes the ball move to the left, right? So if dx is positive, it moves right. If dx is negative, it moves left. Right? If I hit the left edge of the window, right, I'm going to make the ball, I'm again going to flip the value of dx so that it becomes positive, and now it moves to the right. Right? And now all you do is move the point. How do you move the point? It's just pxx, right? So ask the point P to set its x coordinate to the new x value. Right? And then the standard draw class lets you draw simple shapes. So you can draw a circle. That draws a circle whose center point is at px and py, having a radius equal to radius. That 15 is 15 milliseconds. So it displays the image for 15 milliseconds, and then the loop runs again. And that's all it does. Right? And you get this bouncing back and forth effect. Right? And I mean, for most of you, this is not the most impressive example in the world. In 1972, though, this was pretty earthbreaking. So this is, I don't know if you've ever seen this. Oops, sorry. So this is a video game called Pong. It was the first widely released video game that was actually successful. So this was made by a company called Atari, which is still in business today. Right? So in 1972, this video game came out. There's a picture of Pong. Right? It's almost the bouncing ball back and forth, except you can the player one can control this little paddle here, player two can control this little paddle here, and it's basically air hockey, right? You're trying to prevent the ball from getting past the little paddle on both sides, right? Now I know for most of you, having grown up with video games, this is like the least impressive thing in the world, but this was pretty revolutionary back in 1972, believe it or not. So this was a big deal back in the day, right? And you can actually read all about the development of Atari and the game Pong. Funny enough, this was actually a ripoff of another game by a company called Magnasonic, and Magnasonic sued Atari for this. But that's what video games used to look like, right? So you would actually buy something that looks like your PlayStation or Xbox, and all it did was play Pong. Funny, but true. There's a slightly more sophisticated example. So this is actually in the notes. I think it's in the notes. There's a program called Bouncing Ball. You'll notice that it's quite a bit longer. It does some stuff that you won't understand, which is fine. At this point, all you care about is how's the ball moving, right? Well, it's just a point, right? So with just a little bit of effort, you can do something like this. Right? So that ball, if you've taken first year physics, it's just moving according to the equations of projectile motion, right? And it just bounces around forever, right? Whenever it detects the left or right-hand side of the screen, it reverses direction. Whenever it detects the ground, it just bounces up, and so it again reverses direction. Right? You might wonder why it's flickering. It's because this thing, this drawing software that I'm using is not really meant for animation, right? So it doesn't look the best in the world. If you want to program games in Java, there are better libraries that you can use. Right? It is possible to program 3D video games in Java. All right, so you can play around with that example if you are interested in how this works. But really, it's just implementing the simple equations of motion for a projectile. Here's an example of using the scanner class. Don't bother committing this to memory. Right? If someone ever asks you to write a program, though, that reads the keyboard line by line, this is how you do it. Right? So the scanner is just an object that can read. It can read a source of data and parse that source of data into individual pieces. Right? So this one reads the keyboard. Right? The scanner class has a method called hasNextLine. Right? HasNextLine just returns true. As long as there might be more input for the scanner to read. If you're reading the keyboard, hasNextLine always returns true because it never knows when you want to stop, right? Like you can type something in, press enter, type something in, press enter, right? So it always returns true. Right? The nextLine method returns the most recent line of text that was entered by the user, and then they have to press enter. Right? So after they press enter, nextLine will give you that line that was entered, right? And then you can print that line. Right? If you want to stop this program, you have to press Control-C to kill the program, or in Eclipse, stop it in Eclipse. When you're done with the scanner, you're supposed to close it. So you're supposed to close the scanner to release whatever system resources were allocated here. But that's just a peculiarity of the scanner class itself. Right? And there's another example of the scanner class. Right? So this one will read stuff until you type in quit. Right? And then when you type in quit and press enter, it will stop. What do you mean? What do I mean? So this one, you type stuff in, you press enter, it just prints what you entered. If you type in quit and then press enter, it stops, right? So as soon as you type in something that's equal to the string quit, it breaks, right? So it breaks out of the loop, and then the program ends. So that's all this does, right? The point here isn't to learn how to use the scanner class. It's to realize that objects have methods, right? The way you call the method is with the variable name and then a dot and then the method name. All right, so I've done this already before in a previous lecture, right? The question is look, if I'm calling methods on these objects, right, where do I find out what methods these objects actually have? Right, and the answer is they're all documented, right? And so you have to learn how to either, one, read documentation, which is the preferable way to do it. Two, though, a way that a lot of people do it is that they will just search for an answer. Right? Which I guess in the short run solves the problem of figuring out how do I solve this problem. But in the long run, in order to actually learn how to use a class, you need to be familiar with its capabilities, right? So you do have to read these documents, right? So in the previous class, I showed you how to read one of these. I'm not going to do it again, right? It's pretty straightforward, but you do have to try doing this a few times to get used to how Java lays out its documentation, right? If you are used to reading the Python documentation, Java does it in a different way, right? I think the Java way is easier, but you might think differently. Okay, so we're now on to the next set of slides. So this is lecture 8. And we're going to talk about lists in Java. Yeah, question? Question? Yeah, go ahead. I can't hear you. You have to. All right. So a list in Java. So I showed you what an array was in Java, right? So an array in Java, its syntax looks like a Python list. It's not a list. Right? It's an array, right? It has a fixed number of elements. You can't change the number of elements, right? The array always holds the number of, the array always holds the same number of elements in the array, right? A list is very different. So a list is a collection that can hold an arbitrary number of elements, right? 0, 1, or more. Right? So a Java list is the analog of a Python list. The problem is the syntax is really very, very different, right? So it's very different using a Java list compared to using a Python list. You can do almost all of the same things with a Java list. It's just you have to do it in a really different way, right? So there's no square bracket notation, which is the problem. There's another complication, right? So in Java, you can choose between many different kinds of lists. You use them all the same way for the most part, right? But there's more than one choice for you to make, right? There's two main kinds, and almost always you use the one that's called array list, right? So its full name is java.util.arraylist, right? And so it's just the class arraylist. It lives in the package java.util, right? There's a link to its documentation. Well, the version 8 of the language anyway, right? If you want to read about what it can do. Right? So remember, what is a list? Well, a list is just a sequence of elements, right? So there's the first element, then there's the second element, and then there's the third element, and so on and so on and so forth, right? So in Java, a list is also a sequence of elements, but there's a big difference between a Java list and a Python list, right? A Java list almost always holds elements of a single type, right? So a Python list, you can put whatever you want into the list. That's not how it works in Java. So in Java, typically a list holds elements of one type, right? Now, when you use the list, so when you make the list object, you have to tell Java what element type do you want to put into the list, right? If you want a list of integers, you have to make a list of integers. If you want a list of doubles, you make a list of doubles. If you want a list of string, you have to make a list of string, right? So you have to tell Java what is the element type, right? And so you have to use this funny bracket notation, right? The less than, greater than bracket. Right? Now, you don't use this notation all of the time, right? When you use lists, you use this notation. If you use something called a set or a map in Java, you use this notation, right? If you're not using one of these things, then you're not using this notation, right? Later on, we'll see exactly when it is that you need to use this bracketing notation. For now, if you're using like 0.2, you're never using the less than or greater than sign, right, as an element type. It's only for list. Okay, so how do you make a list? Well, a list is just an object, right? So that means I'm going to call a constructor. So if I want an array list of strings, right, then you write its type is array list, less than string, greater than, right? So the element type goes inside of the angled brackets, right? And the angled brackets, they're attached to the name of the list type. Right? So big A array list, that's the name of our list class. Right? Angled bracket string, that's the name of the element type. Right? If you want to make an object of array list, right, then it's new. Right? Array list, angled bracket string, and then I have to call a constructor of some kind. So normally what you do is you make an empty list. Right? And so the constructor that makes an empty list is the no argument constructor. Right? That's why there are these two round brackets here with nothing inside. Right? That's the no argument list constructor right there. Right? So now you have an empty list. Right? That is what you used to have to write. So now in the after Java 7, you can leave off the type over here, the element type over here. Right? So if you make a variable whose type is array list string, then you can make an array list object without having to put the type inside the angled brackets on the right-hand side. Right? The compiler will figure out, oh, they want an array list of string. You still need the angled brackets, or you still should put in the angled brackets. Right? But you don't need to put the element type in on the right-hand side. You'll discover pretty quickly, I bet, that if you don't put in the angled brackets on the right-hand side, it still works. Right? You'll get a warning in Eclipse, but your code will compile just fine. The reason this happens is because the list class, or the array list class, was added to the language quite late, actually. So it was added in version 6, I think, of the language. So quite a few years after the language was first created. In order to add this list type to the language, they had to make pretty significant changes to the language. Well, they had to make a significant addition to the language. They couldn't do it without making that thing there optional. And so best practice is put in the angled brackets, right? But you will find out pretty quickly that if you leave them out, everything still works. Right? I'm always going to put them in on the slides. Okay, there's another limitation with the way Java decided to implement what are called generic types. So your list is what's called a generic type. It's generic in that you can specify one or more types in its creation. Right? So one of the other limitations is you cannot make a list of plain old int, or plain old double, or plain old Boolean. Right? You cannot make a list whose element type is primitive. Which seems awful, but they found a way to work around that too. Right? So you can't make an array list of int. Right? This doesn't work because that type cannot be primitive. Right? It has to be a reference type. So what they had to do is they had to add a bunch of classes that correspond to each primitive type. Right? So for the primitive type Boolean, there's what's called a wrapper class, whose name is big B Boolean. Right? And for the type int, there is a wrapper class whose type is big I integer. Right? We've seen integer before. Right? That's the class that holds min value and max value. Right? It holds information about the type int. Right? But it also serves as the wrapper class for the primitive type int. Right? Notice that car, its wrapper type is character. Right? Int, its wrapper type is integer. The other ones, they all match, except for the first letter. Right? Okay, so every primitive type has a corresponding reference type. Right? Similar to the string class, the wrapper classes receive special treatment by the compiler. Right? So in particular, your Java compiler will try to convert between an int and its corresponding wrapper type, and vice versa when required. Right? So we have the type int here, and its wrapper type is integer. Right? So if I write int I equals 1, that just makes the int value I and sets its value to 1. Right? You can then make an integer object j. Right? You don't have to call new. Right? You can just write equals I, and that works. Right? That won't work for anything that's not a wrapper type, but if it's a wrapper class, this works. Right? So I is an int. Normally, if I want to store an int in some other type, the types have to match. Right? Integer doesn't match int, so normally this wouldn't work. But because integer is the wrapper type for int, that works. Right? So in other words, what happens is the compiler silently makes an integer object whose value is 1, and then stores a reference to that in j. Right? That's called auto boxing. Right? So automatically convert an int, a primitive type, to its corresponding wrapper type. You can also do the reverse. Right? So j, it's a reference type, right? It's a big I integer object. Right? But I can get the value of the int corresponding to the integer object without having to call any method. Right? So in other words, I can make a little primitive type variable k, right? And I can say that k is equal to j, or gets the value of j. Right? The compiler automatically extracts the integer value belonging to j, which is 1, and then stores that in k. Right? So that's called auto unboxing. Right? Automatically extracting the value from a wrapper type to get the corresponding primitive type value. Yes?
Auto boxing work with literals?
Yes. So you can write integer j equals 5, and that's fine. Yes. Okay, so if you want to make a list of some primitive type, don't. Make a list of the corresponding wrapper type. Right? So if I want a list of int, make an array list of integer. Right? Call new. Call the constructor. Right? This is the no argument constructor, so that makes an empty list. If I want a list of little d double, make a list of big D double. Right? And if you want a list of car, make a list of big C character. Right? Notice the constructor call is always the same, right? The thing on the right-hand side is always the same. Right? So you're always calling an array list constructor to make an empty list. Okay, now when you use the list, you just pretend that even though it's an array list of big I integer, you can almost always pretend that it's an array list of int, right? Because of this auto unboxing and boxing. Right? The key word here is almost, right? So there is a situation where this is going to get you into trouble. Right? Okay, so I'm going to make an array list of integer. Its name is t. Right? Now I would like to add the number 100 to my list. Right? And so when you want to add something to a list or append a value to the list, right, the method is called add. Right? So t.add the number 100 means add the integer value 100 to the end of the list. Right? So empty list. After calling that line, your list now has the number 100 in it. Right? When you add an element to a list, the type of the element should be the same as the element type of the list. Right? Now 100 is an int, it's not an integer. Right? But the compiler automatically wraps that int up into an integer object for you and adds the integer value 100 to the list. Right? So auto boxing happens here. Now if you want to retrieve a value from a list, right, in Python you just use the square brackets. You can't do that in Java. In Java you must use the method called get. Right? So t.get some index, retrieves the element at that index in the list and returns its value. Right? So tget0 gets the first element from the list. It's a list of integer, so it returns a reference to an integer object. Right? But I can take the value of that integer object and store it in the variable first without any issues because of auto unboxing. Right? So you don't actually have to worry here that you have an array list of integer instead of int. You just use it the way you want to, and it almost always works. Right? There's only one situation where it doesn't work, and it's the remove method. Right? So the remove method, there's two of them in the class array list, in the list class. Right? So remove followed by an int value, right, removes the element at that index. Right? So if I use the previous slide, right, use the code from the previous slide here, right? So make an array list T, add some elements using add, right? Suppose you add the value 100 and you realize, oh, I want to remove the 100 from the list, right? And so you write t.remove 100. That doesn't do what you want it to do, right? So that removes the element at index 100. If you don't have at least 101 elements in the list, that's going to fail. So if that index corresponds to an element that doesn't exist in the list, throws an exception. Right? So that doesn't work. Right? It doesn't work here. So this is where you get trapped or fall into the trap of treating an array list of integer as though it were an array list of int. Right? If you wrote t remove some string on a list of string, then the list will try to remove the first occurrence of that string. Here it removes the element at index 100. Right? So that doesn't work. What you have to do if you want to remove the integer value, the integer object whose value is 100, is you need to make an integer object whose value is 100. Right? So integer value of is a static method that will make an integer object whose value is 100. Right? And so that works. So this is the one situation you have to remember where a list of primitive type, where you can't treat a list as though it were exactly a list of primitive type. Okay, so what can you do with a list? Pretty much anything you can do with a Python list, more or less. Right? So you have a no argument constructor that makes an empty list. Right? So it's just array list, angle bracket, round bracket, round bracket. Right? That gives you back a new empty list. I'd like to know if the list is empty. Right? In Python, you just write if t, where t is the name of the list. Right? Unfortunately, that doesn't work. In Java, right, you must write if t is empty. Right? How many elements are in the list? In Python, you would write length, right, len. In Java, you ask the list for its size. Right? So that's t.size. Do I have the? I don't. Okay. Add to the end of the list, right? That's the add method. Right? If you want to get an element from the list, right? That's get, and then a non-negative index. Right? Index starts at 0, goes up to size -1. If you use an index that's invalid, you get index out of bounds exception. Right? So typically your program stops running at the point where you use the invalid index. So that's get. You cannot get, so you can't get an element that doesn't already exist. You have to be careful with set. Right? So set is badly named. Right? Set replaces an existing element. Right? It doesn't set the element at an index. Right? It replaces an existing element. Right? So set replaces the element at index 0 with the string goodbye. Right? The confusion here is that people who are new to Java will try to use set to add an element to a list. Right? So they'll make an empty list, and then they'll write tset0 goodbye and hope that it'll work. Right? It doesn't work. Right? Set sets an existing element. So if you have an empty list, there is no element at index 0. Right? So that barfs. If you want to add an element to a list, it's add. Right? If you want to replace an element in a list or using an index, that's set. Can you search a list?
Yeah.
So searching a list is the contains method, right? So t.contains val searches the list for an object equal to val, right? So in other words, it looks at every element in the list and uses the equals method, right? Val dot equals the current element in the list, right? If it's true, then contains returns true. If it's false, then contains returns false. If it processes all the elements in the list and does not find a matching value, then it returns false. If you have a list and you want to add all the elements of a list to another list, that's add all. Right? So if you have another list that has some values in it, I'd like to add all of the values in another list to t, right? Then t add all, another list will do the job for you. Right? There's two variations of remove. Right? So remove using an integer index will remove the element at that index if it exists. If it doesn't exist, so if the index is invalid, you get an exception. T.remove some element value, right? We'll search the list for that element and remove the first occurrence of that element, right? It only removes the first. It doesn't remove them all. Right? If you want to slice a list, that's sublist, right? So that's similar to the Python slice operator. Right? Start and stop, those are the two indexes you would pass to the slice operator in Python. Again, there's no negative indexing in Java. Right? And finally, if you want to make a new copy of a list, right, then the trick here is to call a constructor. Right? So I'd like to make a copy of a list, so the trick is to call the copy constructor for the list. Right? So if you have a list T and you'd like to make a copy of it, just pass T to one of the array list constructors. Right? And then you'll end up with a new list object that you can store in U. Right? Your two lists, U and T, will now be equal. Right? They have the same elements in the same sequence. Right? They are independent. So if you remove an element from U, the list T doesn't change. Right? Don't write U equals T. Right? That's the same problem that you run into in Python. Right? If you write U equals T in Python, you don't get a new list. Right? You don't get a copy of a list. You get a reference to an existing list. Right? To make a copy, you must make a new array list object, right? So you have to call a constructor in Java. Oh, there are the examples. So there's how you translate Python to Java. Right? T equals square brackets, that gives you an empty list in Python. Call the copy constructor in Java. Right? If T tells you if the list is empty, right, theirs is empty. Right? And so on, and so on, and so on. Right? So if you're super comfortable in Python, just refer to this list here, right, when you need to do something in this table here, when you need to do something in Java. Is there something? Oh, there's a few things here. Python lists do a little bit, well, they do different things than Java lists. So one of the things you can do with a Python list is that you can ask it to count the number of occurrences of an object. Right? So T counts ABC, counts the number of strings equal to ABC in the list T in Python. Right? Java lists don't have that ability built in. Instead, you have to use a different class. So there's a class called collections in Java. So the collections class contains many methods that will operate on lists, among other things. Right? One of the methods is called frequency. Right? So the frequency method will count the number of times ABC appears in the string T. There's a question way at the back, I think. Yeah.
What's the difference between using the method .size as opposed to .length?
There is no, I have to be careful with that one. I don't think there is a .length in Java. There is none, yes. So this is one of the differences between Python and Java. So Python treats all sequences the same way, right? So a string is, you can treat a string the same as a list or the same as any other sequence, right? And so in Python, to get the length of anything, it's always length, right? In Java, it's different. So to get the length of a list, it's size, To get the length of a string, it's length, which is confusing, but that's the way the language was created, right? So there is no length method for lists, it's size. Python, you can reverse a list, just calling its reverse method. In Java, you use the collections class, call the reverse method, pass in the list, and the collections class will reverse the list for you. You can sort a list in Python with t.sort, right? So that changes the list so that it's now sorted. You can do it in two different ways in Java, right? So you can either use collections.sort and then pass in the list, or you can write t.sort and then pass in the word null. Now, I've mentioned null, I think, once before. Null in Java means no object. So if you go and look at this sort method in Java. Oh, sorry. So I'm in the list class right now. Somewhere there's a sort. Here we go. So there's the sort method inside the list class. Well, it's actually the list interface, but never mind. Right? So notice that this method here takes in something that looks bizarre. This is the problem with reading Java documentation for new Java programmers. About half of it doesn't make any sense because you can't read it, right? We have no idea what question supermark E means, right? So whenever you see something like this for now, just ignore it, right? When you read this, it's sort, it takes in some object whose type is comparator, right? So if I click on sort, right, it says sorts this list according to the order induced by the specified comparator. So in Java, you can pass in an object that knows how to sort two elements, right? It can tell if two elements are, what their order is, whether one is bigger than the other. That's a comparator object, right? So this lets you sort a list based on some policy defined by some object here, right? If you pass in null, where is it? Somewhere it tells you what happens if you pass in null. Here it is. A null value indicates that the element's natural ordering should be used, right? So that just means for things like integers, it sorts in ascending order. But that's why the null is needed there. All right, what else do we have? Okay, let me do one example and then we'll call it quits for today. Okay, if you want to, one of the most common things that you do with a list is that you end up iterating over the list, right? You want to search it for some value, or you want to find the min or the max, or you want to do something with all the elements, right? So here I'd like to find, I have a list of string. I would like to find the shortest string in the list, right? Find the shortest string in the list. We're going to assume that the list is not empty, right? So we start by assuming the shortest string in the list is the first element of the list, right? So the shortest string is the first element, right? So to get the first element, that's t.getZero, right? What is the length of the shortest string? Well, that's shortest.length, right? Remember the string class has a method called length that tells you how many characters are in the string. Right? You can write a for each loop to iterate over the elements of a list, right? So just like a for each loop in Python or a for each loop for an array, right? T is the name of the list that you want to iterate over, right? The variable, its type, is the element type of the list, right? So the element type of the list is string, right? So for each string S, for each string S in the list T, right? Each time through the loop, S refers to the next element in the list, right? So if the length of S is less than the minimum length, the current minimum length, then I know that I found a shorter string. Right? So my new minimum length is the length of S, and my new shortest string is S. Right? That loop processes every string in the list. When it's finished, you've got the shortest string and its length. Right? So that's one way to iterate over the elements in the list. Right? I guess in the next lecture, we'll look at iterating over a list in a different way. There's actually 3 different ways to iterate over a list in Java. Okay, so we'll call it quits there, and we'll pick this up, I guess, on Wednesday.